Hello, it's Keith here, and this is lesson 5 of the Hello World series of my 6809 assembly programming tutorials. I never thought there'd be a lesson 5 of this series, but there is. The reason there is that someone who bought my book asked me, well, they said, hey, the book covers how to create a ROM cartridge. I would like to create a disk bin. How do you do it? Do you know? And I didn't know, but I did some research and it doesn't seem it's too hard. So I thought, hey, let's make a tutorial on it. If you want to support my content, you can, of course, buy my second book, or my first book if you prefer. The second one covers ARM, Thumb, 65816, 6809, PDP-11 and Risc-V. The first one covers just about everything else. So if you want to support my content, please consider buying them because it really helps me out. Now, we're going to be looking at the Tandy CoCo bin file format today, and we're going to learn how to create a disk image and run it on our emulator. I believe the Dragon format is slightly different, so I won't be covering that. I didn't really have any experience on either before I started learning this, as I say, to answer that question. But let's go over and let's take a look at the example I've got. Over to the source code we go. Okay, so this is the program we've got here today. It's CoCo Hello World bin. Now we do have a couple of options on how to run it. We can either run the bin file directly on the emulator, or we can put it onto a disk image and run the disk image on the emulator. So let's fire this up. We're going to be running the disk image, which is the harder way. We like to make things hard for ourselves, I guess. Okay, so the emulator started, the system's booted here. It's trying to run the DOS file, which doesn't exist. That's a special entry in the header, I believe. I do not know how to make that, I cannot lie. So I've created a basic file called Go. I run this, and we will get a message which says hello world. And you may notice the spelling of world is a bit odd there. Why is the spelling of the world odd there? Well, it helps if you're making these kind of examples to keep changing the text you put in very slightly each time, because otherwise you might find actually your code hasn't been compiling properly and you've been running an old version and you haven't realized. So by changing the text or changing something that's supposed to happen, you can make sure it does happen and you can make sure your code is compiling properly. Now, the Hello World example is basically exactly the same as it was originally. The original ROM version was exactly the same. The way we do things is we've got a pointer to a string, the Hello World message. I use 255 termination in all of my tutorials, so I know a lot of people prefer 0 maybe, but you can just change that. I try and keep everything consistent in all of my tutorials. Otherwise, I would go completely insane. It's covering so many systems. So the print string routine loads in a character from the Y register, incrementing the Y register each time. The Y register is pointed to the Hello World string. We check if it's a 255, and if it is, we return. Otherwise, we run the print char routine, and we keep doing that until we've printed our entire string. The print char routine doesn't use the firmware. I try and avoid firmware wherever I can do it. We're poking the data directly to the memory, the screen memory. Now, the screen memory is at memory address 400 in hexadecimal. And we take our Y position, multiply it by 32 and add our X position, and each byte is a single character. So we've got our X and Y positions in the 0 page, the direct page I think it is, on the 6809. I'm forgetting because I cover so many systems. Anyway, so basically what we're doing here is we're taking the Y position and we're bit shifting that until it's at the equivalent position of 32. So we've effectively multiplied by 32 there. We're then adding the value 4 to the A register there, and if adding the value of the cursor X to the B register there, and so those two combined are the double accumulator, and that has effectively added 400 in hexadecimal and the cursor X offset. And this now means that the X register is the correct position for our VRAM destination for the character we want to write. Now the Tandy CoCo doesn't use a normal ASCII character set. That is actually the character set, including all those weird characters there. So basically, our assembler is assembling ASCII, and I always use ASCII. I always convert in code, which is obviously going to be less efficient, but for multi-platform assembly, it's more sensible, I find, for my multi-platform intent. So that's what we're doing here, and so basically that is what is going on here. So we're converting lowercase to uppercase here, and we are basically correcting for our character set so that we're printing the correct character to the screen. So our input here is ASCII, and by the time we get to this point of writing to the X register's memory address, we have a valid character code for the CoCo memory layer. So that's how we are actually showing the message hello world to the screen. How do we actually create a binary file? Now, when we were creating a ROM file before, we were using the command p2bin to convert the intermediary build file into a ROM file, and we're actually using the same p2bin in exactly the same way this time. So we are assembling with this A SW command here. I'm using the assembler SW, and we are building to this intermediary object file here, and then we are converting that into a binary file. So the P2 bin doesn't know anything about the binary files of the CoCo in the same way as it didn't know anything about the ROM files. We're doing all of the work ourselves. And so what we're doing basically is we've added a header and a footer, if you will, to our program code that are the actual prefix and suffix of the binary file that the CoCo is expecting to receive. So basically the header is a mere 5 bytes here. The first byte is a 00. Then we've got a 16-bit value, which is the length of the data block. And then we've got the address that the data block should be loaded into the memory of the CoCo. So what I've done basically is I've got my program start label here, which is the start of my program code, and that's going to be at memory address 4000. And so I've started the data at 4000 minus 5, the 5 being the bytes of the header here. You'll notice we're calculating the length by taking prog end and subtracting prog start. So prog start here will end up with the memory address 4000 because of that calculation there, and prog end is right here, whatever the length of the program is. And so we're calculating the length of the program, the assembler's doing that for us. And you'll notice we've got this footer here. Instead of a 0 byte, we've got an FF byte here, and that's the it's called the post-amble flag, which is basically just telling it that this is a valid suffix to the file. We've then got an unused word, so that's just 00 there. And then we have the execution address, which is, of course, in this case, the start of our program. Now, if you had a data block at the start, it wouldn't be, but in this case, the first line of our program is executable code, so it's just prog start. So this and this is everything we need to create a valid bin file. Now, if we were being smart, and I'm not being smart, but if we were being smart, we would actually just get our emulator, which I'm using XRAW, to run the binary file directly, and XRAW can indeed do that. So if I just changed that there, so now we're telling XRAW to just run the binary file in by itself. So here we go. And you can see it happened so fast I didn't realize. Hello World has already been written to the screen. It's actually already executed the Hello World program. There was no DOS message, there was no run command I had to run. It all happened automatically. So that is the smartest, fastest way of doing things. However, for a bit of fun, I thought I'd try and create a valid disk image. So in that case, what we're going to do is we are going to run the disk image. So let's fire that up and let's actually take a look at what we have to do first on the CoCo to actually make a disk image that's gonna work well. So the DOS emulator, the DOS system is trying to run here, and I think it actually fails. I think even though it says OK, I don't think it actually ran anything there. So if we do the IR, I think it is. You have to excuse me. All I know about the CoCo as operating system is what I like to learn for this example. So if we do load, I did run before, but if we do load go, go is a basic file, you'll see. So this is something that I've put on my disk as a quick speed up for me. And if I do list, you'll see that this is just saying load the machine code program prog.bin, and it's not specifying an address because of course the address is specified in the file prog start, which is at memory address 4000. And then we've got exec, and that is executing that, which of course is being specified by the exec address here, which is also prog start. So this is our entire basic program, and all I did is do save prog.bas. And if we do that again, we're now saving that to the disk. Of course, it's not changed, but originally the disk was blank. So that's created our bas, and then prog.bin was injected into this disk image. So how do we create the disk image? Well, if we go over here, there is a fantastic set of tools called Toolshed, which are free, and you can use that to work with disk images. So the one we want to use is decb. This is the command for working with disk images. And the first thing I did was decb with disk ini. Now this will initialize a disk image. So I used this to create a blank disk image. And then what I did is I saved the basic file to that disk image, and then I could use that as a template, and then I inject my extra file on the program file every time I run my assembly batch file. So if we go over here, you'll see, go away, we've seen you once before. What we're doing here is we are first copying the blank disk template to our release disk image, And then we're using that toolshed deck B with the option copy. We're copying a binary file. The 2 I think is just a format option. And we're specifying our source file of progbin in that build directory, which is the destination of the P2 bin line. So that is the finished binary file. And then we're specifying the release disk image, that is the one we just created via the copy command, and the destination file name is prog.bin, the same file name. And so that is injecting the newly assembled binary file into the disk image, and then we are running XRAW with that disk image. And then at the moment, the best I've got is running a Go file manually when that emulator starts. If someone cleverer than me could manage it, I'm sure you could create an automatically bootable disk, but I don't know a whole lot about the CoCo, so I can't tell you how to do that. If you want something faster, as I say, I'd recommend you use XRAW with the run command like that, and that will start up immediately. So anyway, there you go. So you can go to my website and download today's example and the build scripts and all that kind of fun stuff and have a go with it yourself. Hope you've enjoyed this and found it interesting. And as I say, if you want to see more of this kind of content, please consider buying my book, because that's how I fund my channel. YouTube pays squat. Thanks for watching today, and goodbye.